So as Aviatar just mentioned, don't forget to update your apps to protect them from React to Shell, because this is a serious CVE, so don't forget to do that. And now that we said this, we can continue. So my name is Schlezinger. I'm an engineer in Vercel. I work on the compute products. And as we were building what we call fluid compute, we had to learn a lot about lots of frameworks, and especially on React Server components. And I was so excited about how they work internally in terms of the backend engineering that I wanted to share it with the world. And we built so many small side projects and like tests to ensure that things work, and they were amazing. So I pitched a talk called React Server Components, Some Cool Patterns, or How to Avoid Use Client. Even though the front-end community is where I belong, I don't work on front-end. Like, I never worked on a major front-end project. I do back-end mostly. So my friends told me, hey, these are cool demos, and you are obviously into React Server Components, and you understand it, but most people don't get it yet. And frankly, some think it's like a ploy to sell servers from the server companies. And even though, like, I know I work at one of these server companies, I promise that what I'm going to show you today is not related to selling servers. But I get if you are suspicious about it. So maybe they told me maybe you should explain React Server Components and what you think is cool about them. So the talk is React Server Components and why I am excited about them. And we're going to learn by building, because I saw Aviatar and I had to write some code myself to show you my Vim skills, and maybe you will laugh at my Vim skills. So let's start with some history. So dynamic web pages are not new on the web, obviously. We had lots of ways of building them before. Some of you may have used them. I used classic ASP, J2EE, even professionally. Rails, Laravel. I didn't use Django, but like the frameworks you see here help people design the web that we have today. And they all work the same way. Some were easier than others. The server received the request, then they fetched data, like the server fetched data, either from a database or from like a third-party API. Then they rendered a template with the data, and all interactivity was done through a form element, which is kind of funny because we see the renaissance of the form element these days. Then we had jQuery and MooTools that allowed us to have some interactivity islands, or islands of interactivity, and it was all done through Ajax, which was originally with XML. Now we have JSON. And then came React and other frameworks like React, Ember, Angular, whatever you picked. And we entered the single-page app era, which was amazing, because now apps, we actually had apps and not just documents that are kind of interactive. And building these apps was so easy than before, like adding just like a loading spinner was so easy compared to what we had to do before that. So it was amazing. I will use that cat often. And the way they work compared to the previous generation of apps is that we had a CDN that we deployed the app to, and we made a request and got back a static HTML. Then the browser fetched main.js, and it rendered the static non-personalized app shell, meaning that it just rendered the app as it is without any user data whatsoever. Then, when it rendered the app, it knew what it needs more to render more stuff. So like it needed to download more routes, like more JavaScript, more CSS, and more requests for user data. Then we re-rendered it again. So it was very easy to deploy, and we saw that like many vendors and people actually just used S3 with CloudFront and called it a day. And it was very performant and very good. But they sent a static HTML. So we saw nothing on the page, or maybe like a logo or a spinner, until we downloaded the main.js and evaluated it. And we rendered a static, non-personalized dashboard. So we started by just rendering the shell. We had we delayed the rendering a lot just to render something that means nothing to the customer. And some frameworks, like Next.js, we had Gatsby and whatnot, that had built-in optimizations, they actually, like the static HTML already contained the non-personalized app shell, which was better, but still, it's not the best compared to the previous iteration of apps. Because we waited to download the user data. So like when we made the request to like app.com/, we started downloading so much information before we actually started downloading the user code. And it's lots of time wasted. It can be seconds before the users see anything meaningful. So Next.js and other server-side rendering framework use that API from React, render to string, to create either like a build-time version of your app or the runtime for server-side rendering. And as you can see, we did data fetching before render to string. Then we rendered the app as it is, synchronously. And then we wrote the HTML and called it a day. And what we got is the same thing as we had with the previous iteration of apps, but we had a nice way to hydrate the app with some client-side state and make interactive widgets. So we had like the best of both worlds, if you want to call it like that. But what about handling deferred data? This is something that we still haven't solved, and what deferred data actually means. So let's say that you go to your favorite social media site. Let's say, like, I don't know, like Facebook, Instagram, X, the Everything app, and you go to a post page. So imagine you press return, and then you wait for like 5 seconds, and boom, you get everything. Like, your entire timeline is there. And maybe we can make it faster by not rendering the comments, right? This is something that most apps do, and most apps did in the SPA world. We just deferred loading some of the content, which is not that urgent to show. So like, comments can be deferred, and the better approach would be to render what is important, and then later on, render the comments, for instance. So the case here that I'm trying to make is that perceived performance is a real concern. Performance is relative to what you actually call, like what the customer actually care about. Because for instance, if the loading page takes 7 seconds, okay, if the page load in its entirety takes 7 seconds, it might feel faster than a full page load of 3 seconds if the urgent thing is rendered first and quickly. That means that we need to optimize for render prioritization, and we did that by using libraries like SWR or React Query, or as Evitar showed, fetching in useEffect, which I know that people hate, but I don't do front end, so it's just a joke to me. And it works like this. So we made a request, the initial request to the server, got back the query data, like we queried the data from the server, responded with the full HTML, the full app being rendered, and then when the JavaScript hydrated, we made a request to an API and queried the data, got back a JSON, and we rendered. And that was fine. But what if we can have a simpler model for this? What if React solved this? Because we want React to solve these kind of problems. And this is where Suspense comes in. And Suspense, to my opinion, is the most important piece of technology that we invented in the last couple of years. You can see here an async function, meaning this is a server component. And you can see that we have a wait get post. The fact that we have a wait get post means that post cannot be rendered without the data coming from get post. And then we render the author, the body, and the comments. But if comments is implemented the same way as post, it means that the comments component cannot be rendered without the comment data. So how can we tell React that comments does not block post? We wrap it in a suspense. This is the whole idea. We tell React, you can render this, just leave a hole there, and we will get to it later. And this is a composable priority solution. Suspense is about rendering priority and not about like, I don't know, like not awaiting promises. It's about telling what is important and what is not. So you can see that not just in the post component, but in your entire app layout. So you can have a layout, a header, and a main section, and the post list, like the timeline of that app, is not like it's less important than the actual navigation of the page. This can stream later, and we know that it takes more time than just the static content, so we can just leave a hole there and get back to that later. So when it's easy to prioritize, the cost of better experience goes down. Because you all did in your apps, some deferred data loading. But if you could do that just by wrapping it with a component, you would have done it more, because it's easy. And we saw that chart before, that we fetch and hydrate, and then make stuff on the client-side rendering. This is how it looks like in Suspense. You make a single request to the server, and the server does not terminate the response until it has the comments rendered. So you don't make extra requests to the server. So how can you stream component data? Let's see it together. It's going to be with HTTP streaming, which is incredible. And, oh, OK. And we're going to do that in Vim together. So are you ready? Oh, my browser is closed. So we will open a browser just to show you that we have a server running port 8000, and it's rendering what we have here, right? This thing is also curling. Every time I save, you will see what's happening on the server, and this is the server logs. You can see that if I change here, I remove the exclamation point, you now see that it's gone. So the first thing we will do is I will show you the trick of streaming. So it's not really a trick, but we can have like two different res.write, and we can have set timeout between them. And await for it, obviously. So you can see in the bottom that we have a low, and then 1 second, and then world. The browser renders it the same way. So we can stream HTML, and it will render as it reads it from the stream. And now we will do something that feels more magical. So let's do res.write HTML. And we'll give it an ID of whole, or like call it spinner, I don't know. And we'll say loading, right? Now we have loading, and we have world. But what we want is we want to replace loading with the contents of world. So in order to do that, because it's a problem, like in a stream, you can't go back, like seek back and change what you've already written. But how can we change stuff that was already written without like being able to go back? So the trick here is, and I know that maybe security experts will be angry, is to write a script tag. And this can be ugly. So like document.query selector and spinner in our HTML would be world. And this seems stupid, but it works, right? So this is the core idea of Suspense. This is the core idea of what we call out-of-order streaming, because streaming is in order, so this is out-of-order streaming. And just to prove it, we can have, let's do this. Oh, we can actually use an emoji. Oh, no. Oh, let me refresh. OK, I can't use an emoji. OK, so, but you can see that this thing here, it doesn't let me edit it. OK. We can see that the div later, like we did not change the exclamation point div. We just changed the loading one. And this is the core idea. So let's try to simulate React. We're not going to use React in this talk at all. So we're going to have an async function called Pokemon. It will get a number, and will return the number and what is the name of this Pokemon. So I already have an endpoint that just receives a name, a function that will return. I don't know how to use a computer. Just a second. OK, so I can get the name back from each Pokemon. And we can write here. Let's make it nicer. Res.write, to HTML. The HTML tag, template tag is just so it will be nicer to render. It doesn't do anything. So we can have like a before, just so we'll see how it works. after. And here we can do await Pokemon 25. Does anyone know who is the 25th Pokemon? It's Pikachu, yeah. So here we render Pikachu, and you see that it's blocking, so it's not special, right? We can look here, and you see that it's blocking. I mean, it doesn't say anything, but you can see here also, like if I will save, oh, we can remove the HTML, this one. So now it waits, and then it prints Pikachu, but this is not what we want, right? So what we want is actually to have a function called Suspense, right? This is what we want to learn here and know how it works. This must return a string, because we will use Suspense here, like an HTML, a string of HTML. And we'll have a fallback, which is what the text is going to be. Let's just start by doing this. So we'll have Suspense, fallback of loading. So what should we render here? We can just do ops.load fallback. And nothing special is going here. We just have this loading string, right? Not special. But we know that we will need, in order to replace it, we will need to wrap it in some element. So let's wrap it in a div tag. And if anyone is offended by using too many div tags, okay, that's okay. Sorry. The storm was very hard. It was like 17 degrees, so cold. Let's just add like style display contents. Now it will not feel like a div. It will just be semantically as div in the HTML. So now what we want to have is we want to have the promise of the content. Like we want to, like this Pokemon component returns a promise of string. So we want to have something like this, Pokemon 25. And if I save, nothing happens because we haven't used that promise. You can see just loading. Very boring. So what we'll do is like we do ops.content.then, and now we have the content we want to render. So here we will log it just so we see that we actually get Pikachu here. And we want to res.write something. Maybe we write the content. The problem here is that we need to write to the response before we end the response. So we need to track the promises somehow. So we will build a very small awaiter class. Maybe there can be a nicer name for this. I don't know. So promises will be we will have an array of promises, and we will have what we call flush. And here we'll do while we have promises. We should await, we should take the promises from the struct, and then set new promises and await for all the promises we've received. So we set new promises, so I have 10 minutes, okay. So it's at 12. So I'm setting a new array in the promises just so if we have a suspense that then calls suspense, we will be able to run twice. We will not await for the same promises over and over again. We will also need, let's call it. So before rest.send, we will do await, awaiter.flush. We don't have an awaiter, so let's create one, awaiter. And here, for our content, we will need to do awaiter.push for that content. Like we will need to wait for that promise to resolve. Let's implement that. This is very simple. And we will do this promises push, promise, and we can ignore all the errors here because we don't want to throw in case of an error. We don't care about it. And now you can see that we sent something over the wire, then the 25, the Pikachu 25. Let me wrap it in a div. So I love divs. So it will just look nicer. And here you can see that we have before loading and then Pikachu when it's rendered. So the last thing we need to implement here is to swap between the new content that we just received and the loading that we had. So to do that, we will need here to write something like a script tag, right, that will replace. So let's create some IDs so we can associate between the two things. So here, when I call suspense, I can say that ID is just like a number taken from the IDs number. And we can give it like data suspense, and then the ID. And we'll do the same here for the content. And for the content, instead of rendering it to the page, we will wrap it in a template tag. So a template tag is a tag that will not be visible to the customer. So we can see that it's actually being rendered here, but if I will refresh, you will not see it here, but you will see it on the DevTools. And we can give this template, data suspense ID. And now what will we have here in that script? So we will need to have some function, like a replace function, and to give it the ID. The cool thing about JavaScript is that you can stringify functions. So we can have replace function that takes an ID. And here we can just query selector div data suspense ID. And now if we don't have a div or we don't have a template, alert what? And then return. This should not happen, right? And here we can say like, I got him, just so we will know that it works. Yeah, so we see here, I got him. So it means that we have the data and we have the elements. So now we can do div.outer.html equals template.inner.html. So the contents of the template will replace the div. We can do template.remove. And we can clean up for ourselves. We can do document.currentScript.remove. So this is like the current script tag will be removed as well. So now it works. And I also have one thing that I can show that is, I think, is exciting. So we have the Pokemon component. We can also have an image component. And let's say that the image is from a resource that you can't actually use, like for cores or like cross-origin things. Like you don't trust github.com that serves the Pokemon images. So here we will do something that is, like security people will say this is much worse, what I'm going to do. So like do not use it in production. It's just to see cool things. We'll just take the URL and we'll call it. This is called SSRF, by the way, this problem. And we'll take the array buffer. This is the buffer. Then we'll do base64 will be buffer from buffer to string base64. Then we can return an HTML of an image. Sorry. That thing will work by doing data image PNG base64, and then having here the base64. So we will embed the base64. Just to show that it works, we will do await image here. And we'll do, here we have sprites. And we'll do sprites.front default. And let's do image. Right? Now we have Pikachu, right? But this is boring, right? We want to, like, why did we wait for so long? And what if we have, like, what if fetching is very slow? Maybe we want to defer this thing. So image can also be suspense. This is less important than the name, probably. So this is the content, and fallback will be an emoji that I hope will work. And this now should, yeah. Let's see it on the big screen. So loading, then an image is not loaded, then we stream the contents of the image. And I didn't import any JavaScript file. So any framework can do this. It's just boring HTML and streaming, which I think is exciting. So what did we do for this? We started by streaming text with HTTP just to show what is streaming and how powerful streaming is. Then we built a small async component, which just rendered the name of a Pokemon. And in order to implement Suspense, we needed to track request level promises within a waiter. OK. And then we extracted a Suspense component. And the core idea is that we schedule a write to the stream and return the fallback immediately. And this is how it looks on a chart. We request slash, for instance. Then we start querying the data and respond with the HTML immediately. Then the data is resolved. We stream a template and script tag to replace. This means we're streaming HTML diffs. And the reason we're very excited about it, like this is a declarative way of streaming that, is that, sorry, that a smart CDN could actually, when you make a request to the root, you start querying the data from a remote function, but the smart CDN can already send you back the app shell, the thing that is not personalized. And then when the data is resolved, we stream it back from the function. We basically take two services, a CDN and an upstream server, and we make them know each other and compound or like join the requests together in a smart way. So the CDN returns the initial HTML, and the function returns the HTML diffs we will need to apply later on, which will make the perceived performance better because we can distribute the static files globally. And it's amazing. So this is what we call in Next.js partial pre-rendering, and it's a cache components feature. And it's very, so we like it a lot, but this is not the topic of the conversation. It's just like this is a feature that came out of the fact that we have Suspense in place. So what I want you to remember from this talk is that when it's easy to prioritize, the cost of better experience goes down. This is something that you can also see on a management track in conferences, but it's also true for web apps. So we need to prioritize everything, what is important and what is less important. And Suspense was the missing piece for that, for React specifically. And the way it works is by having strong cohesion between the front end and the back end. So Suspense can only work and work well when these two work together. And this is why I'm excited about React Server Components. And that's it. Thank you.